cse-304. So this is the standard textbook. I have pasted a URL from this, just click the URL and you will able to this one download that book. And again, one important book is there, Fundamental of Microprocessor and Microcontroller. This is also another interesting book and very useful book. You can download from this one. And again, you can work down and anything, any textbook, any material, any textbook related to the microprocessor or any CSE group, you can download from a one site or less this one. See this one, book. This is download book SC. bookSC.org. You can download from this site. This is very interesting. bookSC.org. This is one of the sites. Okay. And in the meantime, if you're not able to hear the properly or you are not able to see my PPT, just have a this one. Just inform me about this one. Okay. So just note down this this site. From this site, you can download the required material. Not only from the microprocessor part, but also from different for different subjects also. So class timing will be there will be 2 class weekly that will consist of 1.3 hours and 2 hours. And class timing will be intermediate through the one that I had of my class timing. And the attendance is a must. And the attendance will be count. And again, for in the internet assessment, some portion is for the internet marks. So attendance must be there. Your class attendance performance will be very much taken into consideration. So, and the assignment, I will give some assignment and some quizzes also, and that will be required to submit in specific period of time. And the online quiz also will be conducted, and one of the surprise quiz also be conducted on a particular lecture of mine. I will not give extra time for preparation. I will decide in which day. I will not inform to you also, and in a particular quiz assignment on that day, you have to give the exam. Okay. So mark distribution will be, internet mark will be carry this one. Online quiz will be 10 marks, assignment will be carried 5 marks, and attendance will be carried. And usual mid semester carries the 30 marks, and end semester will carry the 50 marks. So coming to our topic, so we have seen the computing evolution. We have come up on the computing evolution because from the starting of the big computer and to the smallest palm computer and this one, there is a loss of improvement in the computing environment. Computing means the device which can compute our tasks. It stays the computing. Computing means computing come up from the word compute, that means to calculate, to compute our tasks in a very shorter period of time. So the computer environment we have seen from the there were in the earlier generation of computer. We have different types of generation: first generation, second generation, third generation, fourth generation, so on. We are in the 5th generation of computer. So in the first generation, when the computer is big, so this whole room is nothing but a computer. In the first generation, we use the beacon tubes for the calculation. This one for the computation part, and so on. This is the innate computer. This one innate that is beginning in the 1970s. So big computer. So and now the computer environment has now changes, and now it is evolved to different types of computer. Now first this one very big computer, innate says innate, and then the mainframe computer, then come the mini computer, then come the PC, then come the mobile computer, and so on. So the size of the computing environment has been reduced. And again, the complexity is joining the class again. Hello, you're not able to see the PPT now? Okay, let me check once. Don't, if you are late, means don't try to join my class. That will hamper, that is hamper in my class. I again need to shift to the PPT to this connection loss. Let me see. Now able to hear and able to see the PPT. Yes? Okay, then we can start. So we have seen the size of the computing environment has reduced to a device we can handle in a pipeline. So the complexity has been reduced also, and again the fast the computational power of the this one device has been also increased. So this is the changing environment. So the computing environment has been changed from the last PC to my device which can fit in my palm. So this is your generation, different types of generation. And in the different types of generation, we come across the mainframe computer, mini computer, the PC, mobile computer, the sensor, the mobile phone, palm top, all these things come into the picture. This other generation. This is possible only when the complexity has been reduced and the processing power that the device can be handled can be increased is so much increasing. This is one law called as a Moore's law. Predicted is the prediction by Indian Gordon Moore. He predicted that number of transistors that can be built on the same piece of information can be double every month. That means he does predict a theory that the number of transistor means it is a semiconductor devices that is installed in my microprocessor. So the number of transistors is increased double for every the 8 years. And this is already predicted in 1965 the Moore law. Now it is still in the buried in the today's scenario also. For the Moore's law, you can see in 1970 number of transistors that is uses in the 404. This is one of the type of the microprocessor. 404 in the 1970 that uses around the 1000 transistor. And again, we are going to study this one, this I04, I05. It's something around the 1907, I05 comes into picture. This one, it consists of around 10,000 microprocessors. So you can see the Intel microprocessor. You have heard about the Intel Pentium 1, Pentium 2, Pentium 3, Core Duo processor. This one, i3 processor, i5, i7, and so on. And the AMD processor also. That is not the Intel one, but this is the example related to the Intel processor. So the number of transistors has been increased. You can see this. As the number of transistors increase, the computation power has been increased. So we can compute our task in a short duration of time. That is the even the Moore's law tells that if we try to increase the number of days in the 13 hours, the number of transistors is double in the 18 months. So this is the scenario, and it's still the Moore's law is applicable in today's scenario also. So where is the microprocessor? If I talk about the microprocessor, where is the microprocessor? Microprocessor is inside a computer. It can be inside my printer. It can be inside my mobile, and so on. Any devices that that has a that has a that has a input device or output devices, and again the LU unit, all those things that has to be processed by something else. That is called the microprocessor. And so microprocessor will be unified in every devices, even in the microprocessor also, in the printer also, mobile also, so on. So typically, is a one type of the microprocessor. This is usually in the PC you will see one microprocessor. Example of one microprocessor. So basic concept of microprocessor. So microprocessor means a computer with a microprocessor has a CPU. It includes the memory unit also, and the input output unit also. So if I say the microcomputer, already this microprocessor will be as a CPU. CPU unit will be a microprocessor, and for the communication between that microprocessor, we need a input devices and the output devices. And if I try to access something or give instruction to my PC, I need to store the instruction in some memory. So it should have some memory for the instruction that has to be provided into the memory. So the memory devices has to be there. So the instruction that is going to face in my microprocessor can be stored for the processing. And after the processing in the memory, we can give the output result to the output unit. So this is the microcomputer. Microcomputer will be having a computer inside the microcomputer. The microprocessor will be as a CPU unit, and the memory and I/O devices will be there. And the microprocessor means a silicon chip will be there, and it include the ALU unit, the elementary logic unit, the register will be there, and again the control unit, control circuit will be there. That will handle all the function. The elementary logic unit will be perform the arithmetic and logic operation. Register unit will try to store the instruction that is faced in my PC, and it will store for the calculation part. And again, the control unit will be for the smooth transferring of the data unit. Data has to be transferred from the input unit to the output unit. So control unit will be there for the data transfer, smooth functioning of the my data transfer. So, and the microphone, one again term is the one microcontroller, and this is also one type of silicon chip that include the microprocessor in my memory and I unit in a single package. If in a single chip, if microprocessor memory and input output devices is present in my single unit, then it is called the microcontroller. I have one diagram in the later part of my PPT. You can see the difference between the microcomputer, microprocessor, and microcontroller. Okay. So what is meant by microprocessor? So microprocessor comes from the combination of the micro and the processor. So micro means it is nothing. It's a small one, 10 to the power minus 6. That means small. It's a small chip. So and a processor means any devices that can process whatever the input is given to you. If a device that handle the processing power, if a device that has the processing power, that is nothing but a processor. So the input in the context of the processor, a device can process the number. Suppose if I enter some number that different 0 and 1, that number has to be processed in my by the microprocessor, and the required output has to be generated and given into the output unit. So this is the processor. So the task of the processor is to process whatever the input is given into the computer. if I give some instruction add a plus b, then addition of two number has to be processed by the processor. According to the instruction, the processor aim is to process the data. Okay. So whatever the data is given, the processor target is to process the data. Whatever the instruction has to be given in the computer has to be processed by the processor. So what about the micro? So this microprocessor in late 1960 processor was built using the discrete element, but in the 1960s, that devices require the devices having a very much high computational power and very slow. So in 1970, now from a discrete element processor was beginning has been invented with a new microchip was invented in 1970, and now the micro and the size has been reduced, and the but the speed power has been increased several times as compared to the late 90s. So micro chip that is embedded, and this micro chip is called the nothing but the microprocessor, has been born in 1970s to handle the different tasks. So is there any, you might be having a question in your mind then, whether the mini processor was there or not. No, there is no any mini processor. From the discrete element to the single chip, we are having a microprocessor from 1970s. Now the microprocessor, even if we have the this one microprocessor, and the microprocessor, different companies, Intel, AMD is there for manufacturing of the microprocessor. So it increased the number of integration. Number of integration has also increased. So what is meant by microprocessor? So microprocessor, if I talk about the microprocessor, it is multi-purpose. It is not for a simple arithmetic logic. For a microprocessor has to be able to solve the arithmetic also, logical process also, and different types of instruction that is given to my PC has to be solved by the microprocessor. So multi-purpose. This is meant for the multi-purpose programmable logic device, and it reads the instruction from the memory and accept the binary data also. And in form of the input will be in form of the binary data, and the process the data according to the instruction. Whatever the instruction is given, if I say add two numbers, then the microprocessor task is to solve that required information. That is the addition of two numbers. Then after the accepting of that binary input, but that information has to be in the binary input, and that instruction has to be processed. That after the process of that instruction, the output has to be shown in the output unit. So basically, the task of the microprocessor is this one. So the definition, again, one definition. Definition of microprocessor. Microprocessor is a programmable devices that text in number, perform them in arithmetic or logical unit according to the program storing memory, and then produce the other number as a result. So this line, this one underline lines has a different meaning. So programmable device. What is meant by programmable device? Take in input, take in numbers means what kind of number it will take, perform on them arithmetic logic means arithmetic means what kind of arithmetic logic will be there, logical operation means what type of logical operation will be there, and store program storing memory. Memory means there might be different types of memory also. RAM, there will be RAM, again there will be ROM, different types of ROM is also there, and different types of cache memory also, different types of memory devices is also there. And then again the produce in which format the output will be diverted in, it will be stored in the memory. It will be studied in details. So let's explain it. The programmable device means microprocessor can perform different set of operation on the data it receives depending on the sequence of instructions supplied in the given program. So a microprocessor performs different set of operation. Different set of operation means there might be different type of instruction. That means the operation, it means there might be a addition, there might be a multiplication, there may be a XOR operation, so on. Different type of operation has to be there, and the microprocessor can perform different set of operation on the data it receive on the instruction and supply to the giver, and the information has to be given in the program. Whatever the instruction that is given in the program has to be solved by the microprocessor. By changing the program, microprocessor manipulate data in different way. So again, the program means is a set of the instruction. If I say the instruction means one instruction, add two numbers, suppose one line of operation, suppose, and again, the program means is a set of the instruction. So if I try to manipulate different tasks according to a convenience of my necessity of the one particular user, so I can manipulate my instruction according to the need of my necessity of my of an individual of mine. I can edit my instruction. So by changing the program means by changing the instruction. By changing the instruction, the microprocessor can manipulate in different ways. So the manipulation can be done in different way. So instruction means specific microprocessor is designed to execute a specific group of operation. Each group of operation is called an instruction set. So the group of operation is called the instruction. There will be so many instruction set. And if we are going to study the i085 and i086 microprocessor in details. And you will see the different types of instruction set there. And that instruction set is already decided by the already inbuilt by the company N. Company N will provide a different type of instruction because we do not know which type of instruction that will. Suppose if I write this one in the C equal to A plus B in the C programming, that will not be understood by the microprocessor. So if I try to change the C equal to A plus B semicolon that is written in the C language to the microprocessor by using the assembly language programming, the instruction that is going to be followed by the addition. One instruction set is there, add instruction is there. So by using that instruction set, I can execute my program. So instruction set will be there. That group of operation is called the instruction set. And the instruction set define what microprocessor can do or cannot be done. Suppose in my instruction set, there is no instruction set for performing a high complexity program. So it cannot be done. Suppose I need to find this one a problem of the shortest root path that is not available in the instruction set. So that will be present in my instruction set because instruction set is already will be decided by the company N, and company N will be provided that instruction set to the individual. Okay. Everybody understanding the till now? Hello? Is a simple one, no? Yes, we can continue now. Okay. So, take-ins, the definition of take-ins means taking the input from the user. The data that the processor manipulate using must come from the somewhere else. So, take-in means the information has to be taken from the input unit. because the instruction has to be given from the input unit. That is take-ins. Take-ins from somewhere. Manipulate. For the manipulation, for the processing part, it has to be taken from somewhere. That somewhere part is nothing but the input devices. That somewhere, from somewhere, that means the input devices. The information has to be come from the input devices. It comes from the input devices. And these devices that bring the data into the system from the outside world, because microprocessor does not know the outside environment. The communication to the microprocessor and the input unit has to be there. Communication has to be there from the input unit. So the instruction has to be provided by the input unit. And this one input unit who can be of a keyboard, mouse, switches, different types of input unit is there. Then again, the microprocessor has a very narrow view of light. It means it can understand only the binary number. So the microprocessor understand only the 0 and 1 in terms of the 0 and 1. So the microprocessor has a narrow line. Narrow line means it does not understand the ABCD. So if I give the ABCD, then ABCD has to be instructed in my binary number, has to be converted into my binary digit. So a binary digit is called a bit. A binary digit is called a bit, which comes from the binary digit. So a binary digit is nothing but a combination of the 0 and 1s. If there is a combination of 0 and 1s is there, that is nothing but a binary digit. So a microprocessor recognizes and process a group of bits together. So suppose if I give an instruction 000 001, that is, it is a group of information. It is a group of bits. That group of bits 001 is nothing but a 1. And the number of bits in a microprocessor, that is the 1. If I say the number of bits, automatically the word come into the picture. The combination of in normal scenario also, the combination of different letters is also called a 1. In same way, the combination of different bits, a group of different bits is called a microprocessor word. And it is a measure of its abilities. And with that, different types of different combination of bits. With the different combination of the bits, different instruction I can set by using the different bits. And we have seen this one, word and byte. Byte means what means is simply a combination of different bits. It can be of two bits, 3 bits, 4 bits, so on. And if it is combination of
हेलो। अभी क्लास चल रहा है माइक्रो प्रोसेसर का। बाद में आएंगे। Sementara cincin apa sih?
B is 0, the output will be for all operator, it will be 0. If 0 is there, and again 1, again 1 is there, again 0 is there, it will be 1 again, 1 in 1 again, it's 1. So it is all operation. XOR operation is also there. So in this way, different types of logical operator can be performed by your microprocessor, and you're going to study the detail upon the logical operator in this logic. So don't need to go detail about that one. But in the assembly language programming, we're going to study the assembly language programming of the i05. Some logical operator will be there. In that time, I will share that information. But it is simple one. You can study. You can study from the digital electronics chapter also. So again, the number and the type of operation define the microprocessor instruction. So if I have a number and type operation, number means some instruction number will be there, and with the combination of the some operation, add operator or sub operation, subtraction operator, with that combination of the some number and the operator, that will be my instruction set, and depend upon the specific microprocessor. So if I have a microprocessor i05, the instruction set of addition of the i05 will be different to that of the microprocessor of i086. So the microprocessor, if the microprocessor is different, the instruction set will be different. Instruction set means it will consist of some number and some operation, type of operation. Type of operation, that means whether it can be an arithmetic one or a logical one. So that combination of that number and operation, that is nothing but my instruction set, and the instruction set is different from a microprocessor to microprocessor. And it is stored in a memory. So memory is usually is there a collection of memory is a collection of storage devices. It storage device hold 1 bit of information. Also, most of the memory storage are grouped into the I storage together can be accessed together. I storage location can be stored. It means suppose if I have a storage unit of 8 bit, that is 1 byte of information, 1 byte of memory unit is there. Suppose if I say 8 bit of location, if I have a 8 bit of location with me, that means I can store my 8 bit of memory in that particular location. That is the memory location. So memory again can be called this one. If I have a 8 bit of information with me, that is called the byte, 1 byte of information, and it can be measured in the kilos, megas, and giga. So kilo means 102 to 4 kb, and mega means 104 to 4 kilos, and giga means 104 mega. So on the memory, different different sizes, different notation of the my memory can be represented by using the mega, kilobyte, megabyte, gigabyte. So again, the petabyte, terabyte is there. So store in memory. When a program is entered into a computer, it store in memory. Then the microprocessor start to execute the instruction and bring the instruction from the memory at one time. So basically, the instruction set that is from the input devices has to be entered by using the input unit, and the microprocessor task is to execute your instruction and brings the instruction from the memory to the output unit. That is a task of the memory. The storage of the input unit and the storage up until the output is not executed to the output end, that is already will be stored in my memory. So my memory is also used to hold the data. So data means is a collection of some bits, useful information. If I say the data means the information, if some useful information or some set of information is called the data. So if I can hold the data, so I can hold my data meaningful information in my memory also. So microprocessor brings in the data from the memory, then it need to bring in means read my data from the input unit, and again they store my result to the memory when it is done, so that the output can be sent to the user end. And again, the producer means the output that is going to be produced should be a readable form. Suppose if I have a microprocessor, that microprocessor perform some tasks, but that and it gives result in some notation form. Suppose in hexadecimal form. Whatever the instruction you have given, your microprocessor has give the result in a hexadecimal add of two number 10 plus 30. But for a complex program, the output has to be not the output will not be understood by the layman people. So whatever the output is going to be given to the user, that should be a readable form. That means a plus b, that is a is 2 plus 2 should be 4 at the output. 4 should be there in the output. So produces means whatever the instruction that is taken by the microprocessor, after the processing of that instruction set, the output should be a readable form. So the result should be presentable to the output device. So output devices can be a monitor, a printer, or a LED, or any other form. So a typical programmable machine system. So if I see a microprocessor, if I have a microprocessor, there will be some memory unit will be there. Some input output output unit will be there. From the input unit, instruction will be fed in the microprocessor, and and that information has to be stored in the memory. And after the calculation by the microprocessor, the memory from the memory, the output will be fed to the output unit. So this combination, microprocessor, memory, and input output operation should be there, because this is the combination. Without using the memory, microprocessor cannot done. We do not able to perform anything. And again, without having the input output devices, you are not able to get the required result. So this has to be there. If I try to develop some even a calculator, a simple example calculator. In that calculator, input devices should be there, output devices should be there, some memory unit should be there, and some microprocessor has to be there. And then, if this three unit has, if this three unit is there in my in that particular device, the device can be function properly. So inside a microprocessor, so this microprocessor, inside this I can partition this microprocessor in different unit. First, I can have a ALU unit. This is a arithmetic and logical unit for performing the arithmetic and logical operation. And again, the controller unit for facing the input from the memory to the microprocessor to the input devices, for the memory to the output devices, all those things we need a control unit. That is the function of the controller unit. And again, inside the microprocessor, some registers should be present. That function of the registers is to hold the data for some small duration of time. Meanwhile, for the calculation part, I need to hold my data I need to store my data to some set of register, or some suppose if I give a instruction, some instruction is given from the input unit, the microprocessor for holding that instruction set, I need some register. We have different types of register: A register, AL register, B register. That will be studied in the microprocessor in the detail part of the different types of register is there. For holding, the function of that register is nothing to hold the instruction. To hold the instruction for it, if I say some AB, the A plus B, A should be held in some register, B has to be held in by some register. So some registers should be there in the microprocessor to hold the instruction set. So for that reason only, we need a array of registers for holding the data while it is being manipulated. While it is inside the microprocessor for functioning and the processing of that instruction unit, I need to have a set of registers inside the microprocessor. So again, the memory we have seen there for storage of your output, the storage of your input devices and instruction from the memory. Again, the instruction will be shared. So memory store usually in the memory store information such as instruction and data in the binary format. So we always send that computer understand, my microprocessor understand only in terms of 0 and 1s. So all the instruction, even if I give A plus B, add A plus B from the input unit, that A plus B, add A plus B has to be converted in the binary form in terms of 0 and 1. And this 0 and 1 has to be stored in my memory unit. So we have different types of memory. ROM is there, RAM is there. ROM it is used to store information and does not send. And again, the RAM is there. RAM is the dynamic initializer. This is not a dynamic initializer. And RAM is fast as computer ROM. Example of ROM is the CD, DVD, all of this. RAM is the for any instruction. Suppose if we play any movie, all those things. If I try to have a use for that storage of that particular task has to be in the RAM, the random access memory. This is dynamic nature. So again, the memory hierarchy. Again, I have another slide in the later part of this slide that will be represented the different types of hierarchy of the memory, and that hierarchy you're going to study in this one again in the computer architecture in the next semester, I guess. This memory hierarchy is there. So by looking at the memory hierarchy, which type of memory is suitable for what type of information, what type of instruction to be performed, I can understand by looking at the hierarchy. It's there in the later part of my PPT. So basically, suppose if I try to execute my instruction set, suppose if I give an instruction add A plus B from the input unit, some that instruction execution model is there. So first, the microprocessor will read the information. The microprocessor will read the instruction set add A plus B. Then add A plus B is not understandable by the microprocessor, so it should be interpreted in the binary format in terms of 0 and 1. And then again the microprocessor again interpret that information in terms of 0 and 1 and then try to process that information and give the meaningful information to the output unit. This is basically the function of the microprocessor. But for that, from the getting the input and giving the output, there will be some function inside that one that is called the circle. We have three types of circle. This one from the reading of the instruction and reading of your instruction set and the execution of the output system. There is some circle in between that one. It is called the. We have three cycles. First, the phases. Phases mean microprocessor will phase its instruction. Phase means takes the input. Phase means I will take the input. I will take the instruction, and then again the decode. Decode means because A plus B will not be understand because the microprocessor understand the language of 0 and 1. So A plus B should be decoded in terms of 0 or 1, and then it will execute in the output model. So this has to be there. If I have given A plus B, add A plus B, this phasing of A plus B will be there. Take the input A plus B, add A plus B, again add A plus B is not understood by the microprocessor, change that instruction in the binary one in terms of 0 and 1. Then after that, it will execute the result. That is, add suppose 10 plus 20, then 30 result has to be shown in there. So this has to be continued till I have given the information. Hello, this one. You can. I will give this one time for the question hour at a later part of this lecture. I will. You can ask. You just unmute your microphone, and we will discuss after the finishing of this one. Whatever the information is there. Whatever the doubt or something like that, you can have a discussion at the part of that. Okay, till now you understand or not? It's simple one. It's simple, the introduction of the microprocessor, how the instruction has to be taken, different types of execution circle, fast phasing of the data, and the phasing of data A plus B, and A plus B is not understood by the microprocessor. So A plus B should be decode. Decode means it would be decode in a understandable in terms of 0 and 1s. Again, and the output has to be shown in the output unit. So this is the instruction. We have three types of instruction execution cycle: phasing, decode, and execute. Three instruction cycle. So machine language. So we have seen that the number of bits that form is what the combination of any group of bits. It can be a combination of 2-bit or 3-bit, 4-bit, something like that. It's nothing but a what. If it is a combination of 8-bit, it's called a byte. 4-bit is called a nibble, and so on. So this bit define the maximum number of combination. So if I have 8-bit of microprocessor with me, if I have 8-bit microprocessor with me, I can have this 2 to the power n, 2 to the power n. One of the I see in the chat box. So if I have a 8-bit of microprocessor, so 2 to the power 8 of this combination, different combination will be there. So if I have a this one high, this one Intel this one microprocessor will, we have the 32. Now we are using the 64-bit microprocessor, also 32-bit microprocessor. So the combination that can be handled by that information huge one. So basically, if I have able to have a different type of combination with me, different type of combination. So different types of instruction I can handle with that higher bit of microprocessor. So basically, if I have a 32-bit of microprocessor with me, different types of combination, I can have a different type, 2 to the power 8, 2 to the power 16, 2 to the power 32. That is huge number. So if I have this type of microprocessor with me, the different combination I can be handled by using that particular microprocessor. So basically, if I can handle the different combination, so basically the time reduction would be there. The fast your PC, fast your devices will be there. If we try to increase the different 8-bit microprocessor to 16-bit microprocessor, 32-bit microprocessor, 64 micro, and so on to the 128 microprocessor. So, however, in most of the microprocessors, not all the combination are used. But suppose for an 8-bit microprocessor, 256 different combination is there. So, but 256 combination, we have suppose 257 combination with me. With higher this value we can handle by the 8-bit. But all this combination is not used by the 8-bit microprocessor. Some is all the pattern form and instruction for the microprocessor. Some pattern will be there. You will understand in the instruction by looking at the different instruction set. By looking at the instruction set, you can see. So 250 different combination is there, but for a 805, we can see this one. For 805 machine language. So 805, we're going to study this one also. So this is a 8-bit microprocessor. So we have seen I can have a 256 different combination with me. So this 8-bit microprocessor can handle only the 246-bit of information. So 246 pattern represent only this is the pattern, and the instruction present is the 74 instruction I can handle by using this 805 microprocessor only. So not a complex instruction I can handle. Whatever the 74 instruction is there, that will be given by the company and of that 805 microprocessor. That particular 874 instruction set will be given by the particular company that manufacture that 805 microprocessor will given that 74 instruction. That with that 74 instruction only I can perform. And this 74 instruction has been from that 463 pattern. That pattern means that combination of this one to the power 8 microprocessor. So 74 instruction set is there for the 805 microprocessor. So because why that pattern? One question is there. Why that pattern? Suppose I can have this one. I can represent 8. Addition 8. Just 8 represent 0, 1, 1, 1, 1, 1. 0111 is nothing but it will represent 8 information instructions that I can given. But it is not convenient to remember the by using a bit information. So some instruction set has been set by the manufacturing unit of that particular form. For the 805, we have 74 instruction, but 74 information is from that particular 246 pattern. Because it is difficult to remember the bit pattern correctly, that usually entered by in a hexadecimal instead of binary. And again, again for the 805, this again for the complexity. Again, this is complexity. For the complexity, for the reduction of the complexity, this binary digit has binary digit can be converted using a hexadecimal form. 3C is hexadecimal. All of you know the this one binary system. I need to explain this one hexadecimal because I need to explain the hexadecimal part also. That's why. All of you know the binary system. 0 means 1 means 001, so on. Hexadecimal, you know the hexadecimal? Comment below, please. Hexadecimal. Yes. So for the hexadecimal, just repetition. 0 and 9, up to 0 to 9. No, sir, hexadecimal. Okay. So I will this one. For the hexadecimal, 0 to 9. Hexa means what? Hexa means 16. I can represent until 15, 60, up to the 16 bit. 16 I can represent. Hexa means 16. Hexa 16. So 0 to 9, and again, if I try to represent 10 has to be represented by using capital letter A, B, C, D, E, F. So for the 0 and 1, 0 to 9, by using my normal number, 10 has to be represented by A, 11 is nothing B, 12 is nothing but C, 13 is nothing but D, 14 is nothing, 15 is nothing but F. So 0 to 16 bit, 16 combination, 0 to 16 can be represented by the so suppose if I have this bit of information. So if I have some bit of information, just divide hexadecimal for conversion of binary hexadivision. Your task is nothing but just divide your number into 4 bit. 4 bit. First one to just count 1, 2, 3, 4. Last 1, 2, 3, 4. And that can be anything. Just count. Just divide this one into here. So 0, 0, 0, 1 means it is nothing but 3, because 0, 0, 0, 0 is nothing but 0, 0, 0, 0, 1 is 1, 0, 0, 1, 0 is 2, and again 0, 0, 1, 1. So this is nothing but 3. So any binary digit, just divide with the 4 bit divide, and again first 4 bit just see the number corresponding. 0011 is nothing but it is 3, and again 101 means 101 is again 12. Just represent 12 can be represented in as 1101. Understand? So this is nothing but 3, and this is nothing but C. So this is the basically in the I0 file instruction set. This instead of this one hexadecimal, usually we use usually the hexadecimal because for the complexity, because it is very complex to remember the information in the binary stream. So for reduction for that complexity, I use the this one hexadecimal. And in the instruction set of the I085, we have 74 instructions. In so many instruction set, we will use the hexadecimal. Not understand? Hexadecimal, understand? How to represent 09 hexadecimal? Just hexadecimal, you need to same one. Nine means I need to represent only 9. So for binary stream, binary number, 9 means what? Some binary representation of 9 is what? If I have a 9 in binary digit, how I can represent 9 in binary one? Not understand. Somebody comment in the comment section. If I have a number 9 with me, in terms of hexadecimal, in terms of binary digit, I can represent this one 9 in binary now. 101. Okay, this is correct. 1011 because 1000 means 8. 9 means 1001. And if I have this one, if I have this one again, 1001 is 9. And again, if I have this is nothing but in hexadecimal, I need to represent only 9. And hexes, ice, I need to write. Symbol is ice. If I write this, it is nothing but in the hexadecimal. Okay. And if I have this one, 10, 101. This is nothing but 10. And this is nothing but A. So if I have this number, instead of writing 1011, I can write as A ice in the hexadecimal. Okay, understand? This conversion, actually this conversion for hexadecimal, you can convert using the 842 method also. This is a binary to this one digital method, or this one digital to binary, or those things you can convert by using this one. So, and again, this one can be you have in the digital electronic part also some conversion might be studied. And again, you need to study this one, different types of number system. Again, you need to study. that will not be come in the exam and again in the syllabus. It is not in the syllabus, but you need to know how to convert a binary stream into the hexadecimal. Yes. Zero means zero. I can represent 001 for a second bit of information. 2 bit of information I can represent 0 as 00 for the 2 bit of information. If I can suppose if I can represent this one 001 as 001. This is not correct. 001 or 001. 2 bit of information or 1. If I have a 1 in 1 bit of information 1, I can represent 1. Okay. 2 bit of information can have a 4 combination. 3 bit of information has information 2 to the power 3. In this way, you can represent 2 to the power 4. 4 bit, I can have this type of combination. 2 to the power 16. So in this way, Arunab Datta, correct. In this way, you need to know this one. This is your normal digital to the binary, and again from the hexadecimal to the binary to the hexadecimal, and again the octal conversion is to the base 8. Binary means base 2, and octal means base 8. That conversion you need to study. The octal concept will not be coming to the microprocessor, but that conversion has to be known. Might be you have studied earlier also, or I don't know, but might be in the digital electronic might be studied, or architecture in the starting introduction portion might be studied. So in this way, you can know the you need to know the conversion different type of, and this hexadecimal has to be conversion has to be used in the this type of instruction, because this is easy to remember this as 3C. So remembering of 0011001 is a tedious task. I can't remember, but I can remember as 3C instead of this one. So by using the hexadecimal instead of the binary, it would be very much not a difficult task to remember this one thing. So this is the hexadecimal. So normally in the hexadecimal has to be there. So if I have a system component, what are the different system component has to be present in a microprocessor, in a device that has a microprocessor, that has should be having a hardware, that is physical devices, and that is nothing but microprocessor, input output devices, memory devices, all those things is nothing but a hardware devices. That complete set of this hardware, program, and software, that device it will be in a workable condition. And program is nothing but a group of instruction performed by the microprocessor. That is called the program, and it is also a set of instruction. It's given to your PC for any type of task. And again, the software is a group of the program. So microprocessor, we have the memory unit, IO unit also, that is already studied. And this again, microprocessor versus microcontroller. So we studied the microprocessor, but what is the microcontroller? In your several also some microcontroller, 1, 2, 3, around 3, 4 microcontroller is there. You're going to study the details working on the microcontroller, but basically what is different between the microprocessor and microcontroller? So microcontroller control the processor, core, memory unit, programmable input, output peripheral. So if I say a microcontroller, if I have a microcontroller with me, that all the processor, memory, and the input output devices in a single unit. In a single unit, if I have a microcontroller, if I have all the this one microprocessor, this one processor unit, microprocessor, and put a single unit, that is nothing but a microcontroller. So microcontroller includes an integrated CPU, memory, and again input-output devices. So microprocessor only contain the CPU, a kind of the user, in addition to the arithmetic using of the dynamic program. Microprocessor include the required component only one chip, but in a microprocessor, the microprocessor has to be present side to side, but input and output devices has to be not in the one single unit. So you can see this one in a microcomputer. If I say a microcomputer, microprocessor has to be there. That is nothing but a CPU, input device, a memory unit, output unit has to be there for a microcomputer. And for the microprocessor, register unit has to be there, ALU unit there, control unit has to be there. But in case of microprocessor, the microprocessing unit, that is nothing but some processor unit. That is nothing. My microprocessor has to be present here. But not as this type of microprocessor. Some processing unit has to be there. If I have a microprocessing unit inside a one chip, this is all in one chip. In a one chip, microprocessing unit, memory, I/O unit, and other variable devices is there in a single unit. There is nothing but a microcontroller. So what numbering system a microprocessor uses? I want to say that microprocessor understand only bit information 0 and 1. So all the instruction has to be given in terms of 0 and 1s. And the combination of different bits is also a word. And we have different word sizes, 8-bit, 16-bit, 32-bit, 64-bit, and so on. So by using the word size only, we name as a 8-bit microprocessor, 16-bit microprocessor, 32-bit microprocessor, 64 microprocessor. So by using the word size, we name the microprocessor as a 16-bit microprocessor or 32-bit microprocessor, 64-bit microprocessor. So a microprocessor is a programmable device. I always say the microprocessor is a programmable device because it takes input from the user, process the data, and fetch the output to the output unit. That is all the programmable device. So we can compare my microprocessor to a piano. There is different types of keys there, and with the different types of key, we can generate different notes. So in a microprocessor also, we can generate different types of program by using different type of instruction set. We can generate, this key is nothing but instruction set. This key is nothing but a instruction set. By using that instruction set, we say that in 805 we have the 74 instruction set. So by using that instruction set, I can generate different types of program, and that instruction has to be stored in the memory. So this is nothing like a piano. In the piano, in some case, by using a different key, we can have a different notes, and in each and different notes is different. And again, by using different programs, by using different instruction set, different programs might be there, and different programs have individual tasks. So instructions are stored in the memory. So memory. So if I have some memory, there might be different word sizes, 0, 1, 2, 3 to the power n. There might be some bit unit. Suppose if I have a memory to the power 3, 8-bit of information. 2 to the power 3 means 8-bit of information. 2 to the power 3 memory is there. So 8-bit information 0, 0, 0, 0, 0, 0, 1. In this way, this is this type of information I can have, and different for 8 question 1, 1, 1. Similarly to this one, this one. This has to be in the memory unit. So in this way, the memory in memory we can represent this instruction or this different bits of information in the different word, and it can be stored in my memory. So suppose given m words, how many bit L are required to address them? Suppose if we can calculate this I to m. So m is the nothing but is a different m word size. So just put in this formula. To the m here is number of words. Given m words means number of words is nothing but 64 MB. 64 MB means why it is 2 to the power 20. If anybody know this, comment below in the comment section. Why 2 to the power 20? 2 to the power 20. Why there is 2 to the power 20? Okay, we try to convert it. We are trying to convert it because correct. Suppose if I want to convert, suppose if I give this was as a 64 kb. Suppose if I give a 64 kb, so this kb it is a kilobyte. So I need to represent in terms of the I need to multiply with the 2 to the power 10 if a kb is there. So basically, for conversion to this megabit to the bit, I need to multiply to the power 20. Okay, understand? If kb is given, only you need to multiply to the power 20 and so on. Okay, understand? I hope you all understand. So memory organization. So my memory, I can organize my memory as a single dimensional array with an address. Suppose I have an address. This is address 0. Suppose in my memory unit, my memory unit can handle only the 8 bit of information. That means this is the address unit. 0 represents the address unit. That my address is nothing but 0. In this address unit, I can have a stream of bits that has the 8 bit of information. So I can represent this my memory as a single dimensional array with an address. This is single dimensional because array means what? Array means what? Array means I have only a dimension. Suppose dimension 8. Suppose this is 8. Suppose so array 0. I can have a array 0. I have a for the 0 unit, for 0 address, I can represent the 8 bit string. So this is nothing but a single dimensional array. I can represent a single dimensional array. So this is also called as a byte addressing. Because why byte addressing? Because for a particular address number 0 can carry a information of 8 bit of information. That's why this type of addressing is called the byte addressing. Because 1 byte of information I can carry in a particular address. That's why it is called a byte addressing. So we have different types of memory. We have different cache memory, serve as a buffer for frequent data access. This is very small and high cost. So cache memory, this one task, the cache memory is required. Suppose when you start your PC, before coming into the RAM, for booting, first you try to boot your PC now. So for the booting purpose, we use the cache memory. Or again, for a very fast, I want to perform my that task in a very fast manner. So cache memory can be used for covering that one. But normally the cache memory is very much limited in size, but it is basically used for that. Suppose booting up your PC, because before the RAM, before coming to RAM, coming to memory, first I need to access somewhere that can be accessed very fast. And again, the cache memory is very much small and the cost is very much high. And again, the RAM can be divided into dynamic RAM and static RAM. Deep flip-flop is called the dynamic RAM that is going to be studied in this one. This is electronic dynamic RAM and uses a tiny capacity in dynamic RAM. So, and again the ROM can be different, programmable. That can be programmed. Is called a programmable. That can be programmed. That can be programmed means I can edit your program. I can edit. I can this one write some program or instruction in that particular memory that is called the programmable. And come erasable memory also. Suppose if I write some instruction in my memory, if I am able to erase that one, is called the erasable EEPROM memory. And again, the electrical erasable EEPROM. And again, erasable electrical erasable can erase a small portion of the one. No specific tool is required. So different types of memory hierarchy. So this is the memory hierarchy. We have the cache, level 1, level 2, main memory. This one, rigid hard disk is there, optical mount, magnetic disk is there. Suppose if I want to perform a very much to register, because suppose addition or some in microprocessor we have the register also now in that one. For that one, we need to some register for performing very high task. And if we try to go off in that in the up direction, the cost for implementing that type of memory will be huge one. And again, the size is also reduced. The access time is very much in a nanosecond. You can see that one nanosecond to very fast for a register, cache memory, RAM, again ROM, optical drives, magnetic tape. Suppose if I want to store the information of a particular company, all the this one I can store by using a magnetic tape, and the cost of implementing of this magnetic tape and hard disk is very much less as compared to the cache memory and RAM. You can imagine the RAM also. RAM it is in the third hierarchy. Around suppose gigabit or RAM cost around 8,000 to 10,000. Suppose if you want to upgrade your PC, you need to this one buy some new RAM install in that PC. So for upgrading, so it costs around this one for a 8 GB RAM around 8,000, 10,000 rupees you need to spend. So, but you can already have a 1 TB of hard disk in around 3,000. So this is basically the difference. If we try to go off in the pyramid, if we try to upgrade the cost is very much high, but the access time is very much less. Access time very much less means the processing power is very much high. But if you go down below, the cost of implementing is very much low, but the processing power would be very much high. In this way, it is the memory hierarchy. So I always told that some useful information you need to study. But this it is not in your syllabus, but you need to understand what is meant by integer. Integer, I can have a positive integer, a negative integer, character. Usually, character is represented by using some code we have the ASCII code, American Standard Code of Information Interchange. ASCII code is there. Suppose if I want to have a F, F can be denoted with some code letter in the ASCII code. So you need to at least go through this one. And for the real part, already we have for the real number, we have the integer and fractional part. And again, the number system. Suppose any number system has a base. Suppose base 10 has a 0 to 9. Binary number has the base number 2, 0 and 1. And I need to know how to convert to the decimal to the binary, binary to decimal, and so on. And again, the octal base number system is there. It is all the base 0 to 7 I can represent, and hexadecimal carries the base 16, 0 to 15 I can represent, and fast 0 to 9, and again the remaining 6 letter I can represent by using the ABCD here. So this has to be, you need to know this one. Might be in the digital electronic, in the integration part, might be this one, this how to convert that one. And this is very much important. Conversion of one system to another, octal to binary, binary to octal, octal to hexa. All those conversions you need to understand. You need to know. And that is not compulsory for the microprocessor, but you need to know. But hexadecimal, you will come into frequent. You need to know this one. Hexadecimal portion will in the assembly language programming. You need to know the hexadecimal portion, number system, this type of number system. Okay, that's the end of the introduction portion. Next, in the next class, we need to study about the this one, architecture of the i05, this one, silent feature of the i05 microprocessor, and again the architecture of the i05 microprocessor. What are the different types of indexing mode? What are different types of the register present in the this one i05 microprocessor? This has to be studied in next class. Okay. So those who have the, what is our syllabus in microprocessor unit? Okay, ASCII, American Standard Code for Information Interchange. Yeah, correct. Syllabus I will forward it in this one to that itself. This lecture PPT, and again the syllabus I will forward it in this one classroom, Google Classroom. And again, till now, I will share the PPT. But till now, 47 students has joined. Around 52 students is there. Somebody has missed the class, and I am taken this very much seriously. But in the attendance part, I can't compromise. No. And again, the notes, you can refer my PPT, and again this one. I all given in this one material portion in this one. Okay, network not good in my areas, but you need to try at least. But attendance, I need to not compromise. I will not compromise in the you need to try. I can have this one, but you need to present my class. Okay. You just need to follow my PPT. You need to follow my PPT again. You need to download the book. This is very much important book, right? Important book. I already given the link, and again, those who are interested in downloading another book, you can use this link. You can find this one, bookse.org. This one side, you can download any kind of book. in this one. You can find different types of book. Foreign author to compulsorily you can find in this one. And again, I have downloaded this one book also from this side also. Okay, so book name I have already in the first PPT. In PPT is already there. The first one is compulsory. You need to follow this one. I am following this one. This Gonkar, Ramesh Gonkar, Microprocessor Architecture Programming Application with the I05. Because you're in your syllabus around past three unit, around 60-70% is related to the I05 microprocessor. Okay. And in the letter 4 and 5, I06 and the microcontroller. So majority portion is there for the microprocessor. And again, for the microcontroller, you can follow this one, DRAM, fundamental or manipulator, this one. And this one first is compulsory one. You need to follow, download this with this thing. Already you just click this in this link, you are able to download the book. Okay. So let's conclude here. If you have any doubt, you can unmute your mic and can ask a question. If you don't have any confusion, I can leave my class. You can. I will this one quit this one. Attendance I have already taken. Okay. I have already taken by using some software. So those who are present in that particular time, you will be have that attended to the attendance. And again, I can't wait this one up to 10 minutes or 5 minutes. I can wait. After then, if anybody try to join my class, I will not able to give the permission to them. Okay, so be in time. And again, be sure to attend my class. And for the internal quiz was there. For that quiz, I will only maximum I will take the supplies quiz. Suppose if today lecture, after the completion of the today lecture, 5 minute time or 10 minute time will be there. I will share a quiz form. But yeah, if we have this one, I will able to take another. But you need to every time you disconnected, that I will not able to rejoin you again because I will be busy in giving the lecture now. So try to there in a area where internet connectivity is very much high. Because in some room, in a particular room also, in a particular home also, there might be some room which has some good connectivity, and the top floor also there might be some internet connectivity, high internet connectivity might be there. So let's stop here. Anybody have the confusion? If no, I can disconnect, stop my presentation to the class. No? Any? Okay. Okay, then I will stop my presentation. Thank you all for your kind, patient hearing. Let's meet at Friday around 10 a.m. Okay. Bye. Stay safe and eat healthy food. Okay. Bye. Bye.
Hey, Govinda. अरे खेला ये क्या
अबे ये क्या है यार, ये क्या है, क्या है
अबे मैं जिम जाने जिम के लिए रेडी
रिकॉर्ड नहीं होता क्या? अरे मैं रेडी हूँ बे, जाने रिकॉर्ड नहीं होता क्या? ना रिकॉर्ड नहीं होता
भाई अभी नेट के लिए मैं घर बदल दूं क्या इसके लिए?
भाई का 1.3 GB खत्म बे।
अब मैं 2 GB खत्म
भाई मेरा
जियो
100
फाइबर
MB
देखे
का बचा है भाई।
उसी के सिखाएगा तो कौन समझाएगा?
फर्स्ट
अब
सुन
भाई
रहे
केवल
सब
200 MB बचा रहे
क्वालिटी क्या
हैं, पूरा नेट ही खा गया।
वीडियो अपलोड करना है मुझे 400 MB।
अरे वीडियो ऑन करना राज, वीडियो ऑन कर।
आइश
ऑन करना वीडियो ऑन कर।
हां कर रहा हूं। ओ बॉडी
अभी सर अगर ज्वाइन किया तो
आगे
सर है तो लास्ट में, सर देख नीचे है, सर का नाम लिखा हुआ है नीचे
नहीं है क्या खोल
com
नहीं है भाई, नहीं है।
आ गया सर
छोटी किस भाई राज ये क्या है सर पे?
सर पे बाल है भाई बहुत सारा।
संजन तुम ही जाने
अब कपड़ा क्यों देखते हैं?
बाल पे बहुत सारा बाल है।
कपड़ा वाली है।
अरे वो बॉडी दिख रहा है ना, अरे बॉडी बिल्डर
तो दिखा दे बॉडी,
सबका शक
दिखा
किसको देखना है भाई, क्या देखना है?
सैंटन शर्टलेस
दिखा दे
क्या देखना है?
भाग गया और कर रहा है।
क्या देखना है चंदन भाई?
क्या हो गया?
साला।
चलो भाई बाय बाय
चलो बाय।
ओके नेट खत्म है, मैं जाता हूं।